friends, today I will discuss the magnetic circuits. In this topic, I will consider first necessity, definition of the electrical circuit, magnetic field intensity, magnetic flux density, permeability, relation between flux density and field strength. So let me consider first what is the necessity of the magnetic circuits. So the magnetic materials are necessary for transferring the power from one place to the other. Similarly, in most cases, the electrical appliances which use electricity, they also need the magnets or magnetic materials. These are used for the storage of data of audio, video tapes, as well as computer disks, electric motors, generators, transformers, relays, lifting electromagnets, galvanometers, and magnetic recording heads. Everywhere, in almost all modern instruments, magnetism is important. Suppose motor or generator was taken into account. In these two instruments or devices, the common things are flux, current, motion. So in the generator also is same, flux, current and motion of the conductors. So in case of generator, conductor will be rotating in a magnetic field so that voltage is generated in the conductor. Whereas in case of motor, a current carrying conductor is placed in the magnetic field and the conductor experiences the mechanical force. That means in these two devices, the common factor is magnetic flux. Means magnetic material is necessary for that. If that is absent, there is no motor, there is no generator. Similarly, for transformers, if there is no magnetic material which couples the primary winding and secondary windings of the transformer, there is no question of transferring power from one place to the other. So similarly in other cases also. So let us see what is the definition of the magnet. Magnet means it is nothing but a material which attracts the iron pieces is called the magnet. So the definition of the magnetic flux density is phi by A and it is represented by capital B, and the units for this is Webers per meter square or Tesla. Another parameter is called magnetic field intensity, is represented by H and is equal to mmf divided by L, where L represents the magnetic path length. mmf is nothing but number of turns into the current carrying by the coil. So that is H can be written as Ni by L, means ampere turns per meter. Similarly, flux we can also write like this: mmf divided by reluctance. So for magnetic materials, reluctance is defined as L by mu A. L means it is the magnetic path length and mu is the permeability of the material that consists of mu naught and mu r. So mu r comes when there is magnetic material associated with it, otherwise only mu naught will be present. Whereas mmf is given by n into I, number of turns, and the current carried by the turns is I. So further simplifying it, we get flux is equal to Ni A mu divided by L. Similarly, we can write magnetic flux density B is equal to flux by area, and flux we can write as like this: ni a mu divided by L divided by A. So after rearranging these terms and A going to get cancelled, then equation becomes like this: Ni by L into mu. So here Ni by L means it's already defined as magnetic field intensity or magnetic flux intensity. So H into mu, or in general we write B is equal to mu H. Now let us see the comparison between the electrical circuits and magnetic circuits. So in both these circuits, Ohm's laws are there. So in case of electrical circuit, voltage is necessary for passing the current in the conductor. Whereas in the magnetic circuits, magnetic motive force, that is MMF, is necessary to force the flux in the magnetic path, and it is represented by N into I, where N is the number of turns and I is the current carried by the turns, and the units for this is ampere turns. Under electrical circuits, current is one parameter, and the equivalent parameter in the magnetic circuits is magnetic flux. So this current can be measured with ammeter, whereas this we can assume it. So it is shown by flux lines. Similarly, resistance in case of electrical circuits, which opposes the flow of current. Whereas in the magnetic circuits, similar term is reluctance. This reluctance opposes the flow of flux in the core. And the formula for this is reluctance is equal to MMF divided by phi. Whereas in case of electrical circuits, R is equal to V by I. Here it is MMF by phi. And the units for reluctance is ampere turns per Weber. And coming to the Ohm's law for electrical circuits, it is nothing but V is equal to IR. Whereas Ohm's law for magnetic circuits, it is nothing but MMF is equal to flux into reluctance of the circuit. Similarly, in the electrical circuit, resistance can be calculated using the formula called rho L by A, where rho represents the resistivity of the conducting or conductor, and units are ohm meter, and A is the area of cross section of the conductor, and L is the length of the conductor, and the units for this resistor is ohms. And coming to the magnetic circuits, the equivalent to the resistance is reluctance S, and its formula is L divided by mu into A, and units for this is ampere turns per Weber, and L is the mean length of magnetic flux path in meters, and mu is the permeability of magnetic path, and A is the area of magnetic path in square meters. So in electrical circuit, the purpose of resistance is to oppose the flow of current in the conductor, whereas in case of magnetic circuits, reluctance offers the opposition to the flow of flux in the magnetic material. So let me summarize here. We have seen what is the necessity of the magnetic circuits, and we have seen the definition of the magnet, and we have seen the definition of the electrical circuit, and we have seen the magnetic circuit definition, and magnetic field intensity, magnetic flux density, permeability, relation between the flux density and the field intensity. And here it can be drawn that electrical circuit has the closed circuit, and there is no magnetic coupling there, whereas in case of magnetic circuit, there is no electrical connection between one coil to the other coil, but there is a magnetic coupling between the two coils, and each coil will produce a flux, and that will link with the other coil due to the magnetic material associated with the two coils. And the permeability indicates the capacity to penetrate the flux in the iron core or magnetic material in the magnetic circuits.